These are maggots from the zombie fly, Apocephalus borealis, emerging from a dead honeybee's neck. A zombie fly is a parasitoid fly native to the United States and Canada, and they were previously known to parasitize bumblebees and paper wasps. Like all parasitoids, zombie flies end up killing their hosts, and now they've been found to also parasitize honeybees. The life cycle of the zombie fly begins when a pregnant female attacks and injects her eggs inside a honeybee's abdomen. The eggs will then hatch into maggots that feed on the insides of the honeybee. And strangely enough, parasitized honeybees will fly out of the hive at night and never come back. As a parasitized bee abandons the hive, she will become attracted to lights and show symptoms of disorientation before dying of infection. In approximately 2 weeks, the zombie fly maggots will exit the bee's body between its head and the thorax. The maggots will then crawl away and transform into pupa, which are the equivalent form of a butterfly's cocoon. Within 20 days or so, adult flies will emerge and fly off to begin the cycle again. Hi, my name is Erica, and my research is focused on answering 2 questions. What is the physiological mechanism behind nocturnal hive abandonment in parasitized honeybees? And do parasitized honeybee workers exhibit changes inside of the hive? To address the first question, I will focus on studying honeybee circadian rhythms. A circadian rhythm is an internal clock that allows us to wake up in the morning and go to sleep at night. Because honeybee foragers are active during the day and display sleep-like behaviors at night, I propose that parasitism by the zombie fly alters honeybee circadian rhythms in a way that allows honeybees to remain active at night before abandoning the hive. By studying the expression of a gene called period, I will be able to determine if a correlation exists between changes in the expression of period and nocturnal hive abandonment behavior. To determine whether parasitized honeybee workers display a change in behavior while inside the hive, I will examine task behavior such as feeding, cleaning, and dance communication in parasitized nurse and forager bees using an observation hive. My results will contribute to our understanding of the impacts parasitic organisms such as the zombie fly have on an economically and ecologically important species.
My name is Maria Jose, and I am measuring whether or not this fly has a preference of host. If this fly had an opportunity to choose a bumblebee, a honeybee, or even just a native pollinator, which one would it choose and how many times? I am measuring this by using
3 plastic chambers, one with a honeybee or bumblebee and the other with a native pollinator or unrelated insect. Chambers each have small holes on the side in order for the female to go through and make her choice. But it's nearly impossible for us to do these experiments without your help. Honeybees and native pollinators are at risk, and they are very essential to our daily lives. Honeybees are economically important for agriculture. Without them, most of our favorite foods and vegetables would cease to exist. Understanding the behavior and physiology behind these organisms will bring us one step closer to understanding the declines of honeybee populations.
Your help will allow us to begin our experiments this summer.
Without your help, none of this would be possible. Thank you for watching our video, and we hope you will contribute to zombie research.